All right, so if you're looking to check some of your work, I'll go ahead and work a lot of these out. I'm not going to work out every problem here. I'll just sort of walk you through some of the basics of each type, and I'll leave some problems for you to do on your own. But I'll at least show you how to do everything that you're going to need to know on the quiz. So first and foremost, definitions. I'm not going to do them because I'll just, what do I do? I don't want to write them out because it's going to take too much time for me. You know how lazy I am. But I'll probably take a picture and send them to you on Remind anyway. So we're going to skip the definition because they're on my board. So I'll just take a picture of what I wrote on the board and send that to you. But let's get into some of the problems. So I'm only going to do one of these here on the left. I'll do number 9. No. Yeah, I'll do number 9. So all you're going to do is, so this will be 5 points on the quiz tomorrow, 1 point for each blank per problem. So for number 9, if you want to write it in standard form, then all you're doing is just rearranging these terms from the biggest degree or biggest exponent to the smallest degree or smallest exponent term. So our biggest degree term is this one with the x to the 5th. 5 is the biggest exponent, so that's the term that we're going to write first. So -3. Okay, just muted you for a second there because the announcement thing. So anyway, so -3x to the 5th. And then the next biggest degree term is the 6x to the 4th. So then you would put that next, plus 6x to the 4th. Followed by the 4x to the 3rd. And then the plus 4x, and then -1. So that's just putting all the terms, just reordering them from the biggest exponent to the smallest exponent. 5, 4, 3, and then that's an x to the 1st, and then the 1 last. So let me write that again. Let me see if I can't clean that up a bit. Let me actually try to zoom in a little bit here on that particular problem. So I have a little more space. So yeah, it'll be -3x to the 5th plus 6x to the 4th plus 4x to the 3rd plus 4x minus 1. So leading coefficient is just the coefficient of the first term when it's written in standard form, or you can think of it as the coefficient of the biggest degree term. So remember, coefficients are just the numbers in front of these terms or a part of these terms. So -3 is the coefficient for that term, 6 is the coefficient, 4 is the coefficient, 4 is the coefficient. But the leading coefficient is the coefficient of the first term, or the term, like I said, the biggest degree term. So -3 is our leading coefficient. Degree of polynomial. So degree of polynomial is asking basically the biggest exponent of our polynomial. So the biggest exponent is 5, as we've mentioned before. So the degree of this polynomial is 5. Now that has a name, by the way. We'll get to that when we write the name in part E, but I'm going to go ahead and put it on here for now. But if it's a degree 5, it's called quintic. And the number of terms. You just count how many terms you have. So you have 1 term, 2, 3, 4, 5 terms. So there are 5 terms, and that has a name as well. If you have 5 terms, you just call it a plain polynomial. So 4 terms, 5 terms, 6 terms, all just kind of get called polynomial. So the name, it's got a first and last. It's based on the degree and its number of terms. So in this case, it's quintic because it's the 5th degree, and polynomial because 5 terms. So quintic polynomial is the name. All right, now if you're wondering where the names are, go back and there's notes that I handed out one day when we were in the library. Those notes, I gave it to you. I said, hey, the notes are already filled out. You just have to do the backside. That was the day we were in the library because of the ceiling. So if you have that, it's got a chart on it. It'll have all the names on that chart. So find that and you're Gucci. All right, anyway, moving on. Moving to the adding, subtracting. So I'll do 1 adding and 1 subtracting problem. And I'll let you handle the rest. So adding is pretty straightforward because all you're going to do is just simply combine your like terms, and subtracting you're combining like terms as well, but it's less straightforward because of the minus sign. So for number 12, you're going to notice you're adding because of the plus sign in the middle. You're not using a table or anything here. We'll use a table for when we multiply, but we're only adding. So keep in mind, if you're only adding, you're just going to find like terms and you're going to stick them together. So 4x squared and 5x squared are like terms, and we're going to add them, and 4 and 5 makes 9x squared. You don't change the exponents at all. That's when you add terms, you just add the coefficients, leave the exponents alone. It's only when you multiply terms that you add the exponents, and we'll get to that later. But adding like terms, just add the coefficients, keep the term. All right, I always start with the biggest degree as well, so that's why I started with the x squared. So now I'll work my way to my x term. So I only have this 2x here, it doesn't combine with anything else, so I'll just bring it down as part of my answer, plus 2x. And then I have my -1 plus -2. So just combining them, -1 and -2 together makes -3. So that is the answer number 12. Just find your like terms and put them together. Now number 13 is a little less straightforward. So here's what I do. Because we're subtracting everything in this parentheses here. So what I do is I distribute that negative, or in a sense, I subtract at the very beginning so that all I have to do is combine like terms at the end. So if you're subtracting a -3x to the third, minus 3 just means a positive 3x to the third, right? Those two negatives make a plus. So if you can write plus if you want to, but it's a positive 3x to the third. Subtracting an x squared, so again, that's going to make this a minus x squared, and subtracting a -2x. So again, the double negative thing will make that a plus 2x. So I go ahead and I just distribute that negative, write down the polynomial now. Basically, all the signs are just changed, and then I'll combine it with these terms. Now, I don't have to change these terms because they're in front of my minus sign, so if you want to write them down again, you can, but they're not going to be any different. So now just combine your like terms. Just find your like terms and put them together. So notice we've got an x to the third plus 3x to the third. Those are both x to the thirds, and 1 x to the third plus 3x to the third makes 4x to the third. There's also some x squared. So I have a -3x squared and a -1x squared, and -3 minus 1 makes -4x squared. I also have, well, I don't have any other like terms, but I have my 2x. It doesn't combine with anything, so I'll bring it down. Again, I'm bringing down a plus 2x. So a lot of people, if they don't do what I did here, they look at this minus 2x originally and think they're going to bring the minus 2x down. But they're forgetting that they're subtracting that minus, which turns it into plus. Now, people wonder what you're subtracting it from. And technically, you're not really subtracting it from anything. But if you want to imagine, you're really subtracting it from 0x, right? There's 0x in this first polynomial. And if you take 0 and you subtract -2, then you're taking 0 plus 2, and it turns into positive 2 anyway. So you can think of it kind of like that. This is the reason why, but if not, it doesn't really matter. And then bringing down this plus 1 as well. So there's your answer. So subtracting, it's the same thing, just combining like terms, but be very, very careful with your whole minus thing, okay? Because people get those things wrong all the time. Let's move to multiplying. So with number 16, I'll just do that quickly. It's just distributing. So 5x to the third times 2x squared. So you're multiplying the coefficients. 5 times 2 makes 10, and then you're adding these x's. So x to the third and x to the second makes x to the fifth. 3 and 2 make 5 when you add them. All right, again, you're multiplying. 5 times -7 is -35, and that's an x to the third with an x, so it makes x to the fourth. And then 5x to the third times 1. 5 times 1 is just 5, so it's 5x to the third. So there's your answer for number 16. Number 17 is where I make a table. So I set this up as, it doesn't really matter which terms you write off to the left and which ones you write on top, but I'll just go ahead and write the 2x squared, 2x, and -1 off to the left. So that's this polynomial. And I'll put the other one on top. So x to the second, -3x, and -5. And so now I'll just multiply them together to fill out this table. So 2x squared times x squared is 2x to the fourth, because it's 2 times 1, which is still 2, and then you add those x's up, you get 4 x's. All right, 2x times x to the third, that's going to be, or x squared makes 2x to the third. Negative 1 times x squared makes negative 1x squared. 2x times negative 3x would be negative 6x to the third. This would be negative 6x squared, and then a positive 3x. And then this one would be negative 10x to the second, negative 10x, and positive 5. So I'm multiplying. My multiplying is done. Now I have to write my answer out. So to write my answer out, I just combine like terms. So I look for the biggest degree term first. And I notice, hey, that 2x to the fourth, there's no other x to the fourth term. So I'll just write it as part of my answer. I've got a couple x to the third terms, though. So that's a 2x to the third minus 6x to the third. And 2 minus 6 makes negative 4. So negative 4x to the third. Again, when you add terms together, because that's all you're doing here is when you find your like terms, you're adding them together. You don't have to change the exponents, okay? You're just adding the coefficients, just like we did in on the last like 2 problems ago. All right, look at your x squared. You have a negative 1x squared, negative 6x squared, and negative 10x squared. So if you combine them, that's all negative 17x squared. Then you've got your x terms, so 3x minus 10x. 3 minus 10 makes negative 7, so negative 7x. And then the 5's all alone, so plus 5 at the end. And there's your final answer. So division, I'm going to write the steps down, and you can screenshot it or whatever you want to do, but I'm going to write the steps down, then I'm going to erase them and just do the problem because I don't have enough room, I don't think, for all of that. So the steps are, step 1 is divide. And when you divide, it's the first term inside divided by the first term outside. And then that answer goes on top. Step 2 is multiply. So when you multiply, it's the answer from step 1 multiplied to the outside polynomial. Step 3 is subtract. So that's going to be, when you subtract, the first terms are always going to cancel. You'll see what I mean when we work a problem out. First term cancel. And the most important thing is the second term, you kind of just change the sign or think of it as opposite sign. Again, I'll explain that when we do a problem, but that's probably the thing that people make the most mistakes on. And then step 4 is just bringing down the next term. So I'm going to erase this because I need this space to work the problem out. So this problem is going to be a long one, so I'm going to try my best to write kind of small so it all fits, but let's give it a go. So how we set it up, this is the divisor, so this goes outside, 2x plus 4. And then inside, we're going to put this polynomial in standard form, 2x to the fourth minus 6x to the third. Now here's the part that people forget. There's no x squared term here. So I have to fill in a 0x squared for that part. Plus 6x plus 3. So make sure you fill in the 0x squared. It's something people forget all the time. So step 1 is divide. So I'm going to divide the first term on the inside by the first term on the outside. So 2x to the fourth divided by 2x. 2 divided by 2 is 1. And then x to the fourth divided by x makes x to the third. So that is x to the third. And then I multiply that answer, that x to the third. I'm going to multiply that with both these terms. So x to the third times 2x makes 2x to the fourth. And x to the third times 4 makes 4x to the third. And I put those answers underneath those corresponding like terms in the problem. And step 3 is subtract. So when I subtract, the first terms are always going to cancel out. And then you have to think, because it is plus 4x to the third here, but we're subtracting it, you have to think the opposite of that sign. So think of this really as minus 4x to the third. So negative 6 minus 4 is negative 10x to the third. So that 4 is to bring down the next term. All right, so we'll start for step 1 again. So we're going to divide the first term on the inside, which is now negative 10x to the third, divided by the first term on the outside, which is still 2x. So negative 10x to the third divided by 2x. Negative 10 divided by 2 is negative 5. And x to the third divided by x is x squared. So negative 5x squared. Now take that, negative 5x squared, and multiply it to 2x plus 4. So negative 5 times 2 is going to be negative 10, and x squared, x makes x to the third. And negative 5x squared times 4 would be negative 20x squared. So again, put them underneath the like terms, and then subtract. So first terms are always going to cancel, and again, this is opposite, so you have to think of this as plus 20. So 0 plus 20 is 20x squared. We'll bring down the next term, 6x. So again, first term divided by first term. So 20x squared divided by 2x is 10x. Because 20 divided by 2 is 10. And then the x squared divided by an x is an x. And then multiply 10x, the polynomial up front, and put that underneath. So 10x times 2x is 20x squared. And 10x times 4 is 40x. So subtract again. First terms are always going to cancel. And again, think of this second part as opposite. So think of that as a minus 40. So 6 minus 40 makes negative 34. So we have negative 34x. And then we bring down the 3. All right, so again, one more time, we got to divide the first term on the inside, which is negative 34x, divided by the first term on the outside. So negative 34 divided by 2 is negative 17. And then x divided by the x means those x's cancel. So it's just negative 17. And then step 2, multiply that with the polynomial up front. So negative 17 times 2x is negative 34x. And negative 17 times 4 is negative 68. So and then one more time, subtract, the first terms cancel, and I have to write off to the side here, but this is, remember it's minus 68, but you have to always change this. Think of this as plus. So 3 plus 68 is 71. So my remainder is 71. So my final answer at the end of the day is everything I just wrote up here with the remainder of 71. So that would be x to the third minus 5x squared plus 10x minus 17, and then plus 71 over 2x plus 4. So that would be your final answer. That's how you'd write your remainder. Remember, your remainder is always written as that fraction. You write it over whatever the divisor is. So the divisor was 2x plus 4, so I wrote it over 2x plus 4. All right, so if you need more work on long division, please go back and review the long division video. If you go to my YouTube page, just click, you just search Blake Morley on YouTube, and you'll find it, and there's long division problems that I did. And you're welcome to watch those if you need any more help. Synthetic division, I'm only going to do one of these because they both work out the same way. Okay, but synthetic division. So remember, you have a box over here in the corner, and that's my a value. The a value is the root of this. So it's usually just the opposite of the number here. So that's a plus 3, so the root is negative 3. And again, that's because x plus 3 equal to 0. If you actually solve for x, x is equal to negative 3. So that's why we're using negative 3. But like I said, it's most of the time just the opposite of that number. So negative 3. And off to the side here, we're going to write the coefficients of the polynomial here. So 5 for 5x to the third, negative 2 for negative 2x squared, 3, and negative 1. Okay, now keep in mind, if you have any terms missing, like you do here in number 21, I'm not going to do number 21, but notice it doesn't have an x term. You need to make sure that you use 0 in that spot. So the coefficients in 21 would be 7, 1, 0, and 5. Because it's 7, 1, 0, and then 5. But I'm not going to do that one, but make sure you, when you set that one up, that's where you set it up. So now, that's the setup. So you always bring the first term down, don't change it. 5 stays 5. Whatever goes below this line, multiply it to my a value, which is -3. So 5 times -3 makes -15. We put that under the next term, and we add these terms up. So -2 minus 15. When I say add, it's really just kind of combine them. It's a -15, so it's minus. That makes -17. And then multiply -17 with -3. And that is... let me grab a calculator. 17 times 3. 51. Positive 51. So that goes there. And then you add these terms. 3 plus 51 makes 54. And then again, you multiply 54 with -3. 54 times -3 is -162. And then combine those. That's going to make a -163. So remember, this is always my remainder at the end. This is my, not my x. This is my constant. Then this is my x. And this is my x squared. So my answer is 5x squared minus 17x plus 54. And then the remainder, 163 over x plus 3. All right. And so number 21 works the exact same way. Just make sure you're careful and stuff. One more, the last one, number 22. So this is the same thing as synthetic division. It's not going to work out any differently, but there's a connection I want to make here. So in all the division problems, the remainder is the y value for your a value, but your a value is really an x value. So in that last problem that I just did, it was, I think the a value in the box was -3. So that's referring to x being -3. And the remainder for that one was -163. So x was -3, and the remainder was -163. So the remainder is really the y value for that x value. If you plug that x value in to that function, you would get a y value of -163. So it's kind of a neat connection that they have, that the remainder is sort of the y value. So here, when it's asking you to do synthetic substitution, it's the same thing as synthetic division, but you're just looking for the remainder because the remainder is the y value, and that's what this question is asking for. So you could plug in this 3 in for x, and it'll tell you the answer, but on the test, I want to see you do it this way. I want to see you get the answer this way. But if you want to check, you're more than welcome to plug that number in and check to make sure that it works. So how it works, same as synthetic substitution, but you don't have to change the sign because it says explicitly here that x is 3. So if it ever says like as a binomial, then you have to change the sign. But this is saying that x is 3, so we're using that as 3. So the coefficients are 1 for 1x to the second, -6 for -6x, and -1. So it works the same way. Bring the 1 down, multiply that with 3. 1 times 3 is 3. -6 plus 3 is -3. And -3 times 3 is -9. And -1 minus 9 is -10. So that's my remainder, and that is my answer. So my answer is just the polynomial, when I plug in 3, is equal to -10. So the answer is -10. And again, if you want to check, if you plug in 3 here for x, it would equal -10. 3 to the second power minus 6 times 3 minus 1. This would be 9 minus 18 minus 1. This makes -9, and -9 minus 1 is -10. So plugging in the value gets the same thing, but I need to see this work tomorrow for your points. But like I said, if you want to check to see your answer's right, that's a good way to check to see that your answer's right. So that's going to be it. I'll wrap it up. Try to keep it short. Good luck. If you have any questions, just hit me up on Remind, and I'll be happy to get back to you. So I'll see you guys tomorrow.